The search for extraterrestrial life has captivated humanity for centuries. We've pondered whether we are alone in the universe and sent probes hurtling through the cosmos in hopes of finding an answer. But what if the answer has been with us all along? What if the key to discovering extraterrestrial life lies in the very air that we breathe? That may sound crazy, but it's not as far-fetched as you might think. You see, we've recently received a puzzling signal from a faraway planet called K218b. And it's not what you think. It's not lasers or moon dust. It's something weirder. Something like the scent of the sea after a storm. Salty, earthy, kind of funky. Like Earth's ocean, but not quite. This bizarre odor could be the strongest hint we've ever had that life exists beyond our planet. And it's all thanks to a molecule called dimethyl sulfide, or DMS for short. To understand this strange tale, we need to talk about K218b. It's an intriguing planet located 120 light years away in the constellation of Leo. Discovered in 2006, it's roughly twice the size of Earth and orbits a small dim star. That's about as exciting as it gets, at least until you realize that this planet could have oceans. That's right! Thanks to its size and distance from its star, scientists believe K218b could have liquid water on its surface. And if there's water, well, you never know. Maybe there's life. Now you might be thinking, hold on a minute! Just because there's water doesn't mean there's life. You can have water without life. Ask any desert dweller, and you'd be right. But here's the thing, scientists believe that on Earth, life and water are kind of linked. We've seen water seemingly everywhere in our solar system, and yet we only have confirmed life here. Sure, we're biased, but given the lack of life elsewhere, scientists are starting to think it's the water itself that creates the conditions for life to flourish. In 2022, researchers analyzed K218b using the Hubble Space Telescope and discovered that its atmosphere contains carbon dioxide, methane, and water vapor, which means it could have a thick atmosphere and vast oceans. Sounds promising, right? But let's not get ahead of ourselves. These gases could have arrived there through random cosmic events. They don't necessarily mean there's life. That's where dimethyl sulfide comes in. You see, on Earth, DMS is produced by phytoplankton, tiny marine organisms that drift in our oceans. When these microscopic wonders die or are eaten, their cells burst open, releasing DMS into the air. That's what gives the ocean its distinctive smell. And it's not just a pleasant aroma. DMS plays a crucial role on Earth. It helps form clouds, regulates our climate, and even acts as a communication signal between species. So if we found DMS on a faraway planet, well, that's not a coincidence. It's a sign of life. Of course you might be skeptical. After all, there are plenty of ways to make DMS without life. Volcanoes, chemical reactions, explosions. But the thing is, DMS is not easy to make. On Earth, it takes enzymes, cell walls, and specific metabolic pathways to produce it. Basically, it's something you'd expect to see on a planet with oceans. Not a random gas cloud. But here's the catch. We don't actually smell anything in space. What we do is analyze the starlight passing through a planet's atmosphere as it passes in front of its star. That's called a transit. And during a transit, the starlight is filtered by the gases in the planet's atmosphere, leaving behind a barcode of its chemistry. And when astronomers studied K218b, they saw something interesting. The starlight that passed through its atmosphere had a peculiar absorption line, suggesting that certain wavelengths of light were being absorbed by specific gases. Specifically, they saw signs of carbon dioxide, methane, and water vapor. But there was something else in the mix, a slight dip in the spectrum that indicated the presence of a molecule that absorbs light around 1,650 nanometers, a wavelength where DMS shines. Could this be the same molecule that gives our oceans their distinctive smell? We don't know for sure, but it's a strong possibility. And if it is, it suggests that K218b could have a thick atmosphere and vast oceans that could potentially support life. But wait, this story gets even weirder. You see, when astronomers try to detect DMS in space, they typically look at its reflection. DMS molecules absorb ultraviolet radiation and re-emit it at longer wavelengths. And that's what we're seeing from K218b, the re-emission of reflected light. But this time, researchers decided to look at the other half of the equation. Instead of studying the light that bounced off DMS molecules, they focused on the light that passed straight through them. And that revealed an absorption line, a clear sign that the molecule was absorbing specific wavelengths of light. Now you might be wondering, why not just look at the absorption line to begin with? Well, it's all about context. Astronomers are constantly bombarded with data. Every star, every planet leaves its unique mark on the cosmic canvas. So they look for patterns against a backdrop of noise. And in this case, the absorption line produced by DMS is a weak signal. It could have come from something else entirely, like a type of ice called amorphous solid water. That's why scientists are so cautious. They don't want to jump to conclusions, they need more data. So for now, it's a biosignature candidate, but who knows what tomorrow will bring. The scientific community is buzzing